Welcome to this knowledge transfer session. The goal of this session is to share a simple concept that will assist new business rule developers to become comfortable writing calculations as efficiently as possible. This session will help you get started, but practice and experience are still the only methods for building capability with this tool. Bear in mind that EPBCS is built on the Essbase database. Essbase stands for Extended Spreadsheet. It is both a multi-dimensional database and a calculation engine. It is assumed that viewers have experience with other programming languages and also with Microsoft Excel. It's assumed that viewers know what dimensions, hierarchies, and blocks are in the context of a multi-dimensional database. Now here is the simple concept. Business rules have a small number of components, and they're organized in a certain way. If you understand that organization and you understand how to work with each of the components, you will be able to modify an existing rule, debug an existing rule, and eventually you'll be able to write your own business rules. You see the organization or the structure of a business rule before you. A business rule generally starts with some special comments called a header that tells us who wrote the rule, when they wrote the rule, and tells us something about the history of the rule. Set statements basically set up the Essbase environment. Throughout the rule, we have comments, and those comments can be associated with an entire fixed block or with certain lines in the code. They just tell us what the code is doing. The fixed statement designates the cells over which we're going to loop. It's almost like a for next statement in some other programming languages. Those cells that we loop over will also be the target for our calculations. The result of the calculations will go in those designated cells. Within the fixed statement, there are one or more assignment statements. Each assignment statement is broken down into two components. There's the left-hand side that tells us into what cell the result of the calculation should go, and there's the right-hand side that defines the calculation. It says where to get the data that we need for the calculation from the cells within the database, and what operation should we perform. That is, should we multiply, divide, subtract, or should we use one of Essbase's functions? Now there are more advanced structures for business rules. For example, we can have nested fixes, or we can have completely independent fixes. And how a business rule is structured will determine both how it functions in terms of what it calculates and how it functions in terms of its performance. For the purposes of this session, we'll focus on the simpler structure that was shown earlier. Now here we have an example of a header. A header, again, is just a special comment that we put at the very beginning of the business rule that gives us some general information about that rule. First, notice a couple of things. When we want to start a comment, if you look at the top of the code, it starts with a slash and an asterisk. Then we have our comment, and to end the comment at the very bottom, you'll see the asterisk and then a slash. Also notice the use of a fixed width font. If you use a variable width font, the business rule will appear very poorly formatted. If you use a fixed width font, the business rule will appear very nicely as you see before you. At the top, we provide some basic information. The author, the company, the date. We indicate what is the purpose of the business rule. And at the bottom, we have what's called a revision history. So after we've released the 1.0 version of the application, any changes that are made after that point will be recorded, and there'll be some comments or descriptions that describe what's changed. Now, the set statements are used to configure S-base settings for the purposes of the calculation. Among the things that they are used to do is to ensure that S-base calculates the correct results and to ensure that the calculation is processed in an efficient manner. Some examples of set statements are shown on the screen. One very important thing to notice is that each of the set statements ends with a semicolon. And that's true for assignment statements and other types of statements within the business rule or S-base language. Every single line that's an assignment statement or a set statement should end with a semicolon. Now here we see an example of a fixed block. A fixed block is formed from selections on various dimensions. The intersections between those selections will define the blocks and the cells over which the calculation executes. Those intersections will also define the destination blocks and destination cells where the results of the calculation will go. In a way, they're like an extension of the left-hand side of the assignment statement. Between each selection in the fixed statement, we place a comma. We don't put any semicolons within the fixed statement. By convention, we make our selection for each dimension on one and only one line. And this helps us keep track of which dimensions we've accounted for and which we haven't. We have the choice when we're making our selections to use explicit member names, runtime prompts, substitution variables, and functions that return members. For the scenario dimension, we've used an explicit member reference. We've selected the actual scenario. For the years dimension, we've used a substitution variable, working year. And we see that it's a substitution variable because it is preceded by an ampersand. We've used a runtime prompt together with a function for the department dimension. And we can see the runtime prompt, what department, because it's enclosed in curly braces. For the account dimension and the period dimension, we've also used functions. And we can see for the period dimension, it's a simple function. For the account dimension, there are nested functions. The left-hand side of the equation, in addition to the fixed block, indicates where the results of an assignment statement, where the results of an equation should go. That is, the left-hand side of the equation is the destination for the data processed by an assignment statement. Another very important point is that the left-hand side of the equation must refer to a member from a dimension that was not designated within the fixed statement. That is, if you made a selection on the account dimension within the fixed statement, you could not put a member from the account dimension on the left-hand side of an assignment statement. The right-hand side of the equation is where the real work occurs. The right-hand side of the equation has two functions. They are to identify the source cells for the calculation. That is to say, if we're saying amount equals to rate times volume, Rate and volume is where we're pulling data from within the database. And then we specify the operations being performed. That is to say that we're multiplying them. On the right-hand side of the equation, we can use numbers. We can use mathematical expressions, plus, minus, multiply, divide. We can use runtime prompts. We can use substitution variables. And we can use S-based functions that return numeric values. There are reference materials provided by Oracle that detail the syntax of the business rule S-based language. Here, we're going to go over some of the basics. Now we have our assignment statement, amount equals volume times rate. Of course, it ends in a semicolon, and for multiplication, we use the asterisk. When we refer to a member, say volume, we can simply type in its name. But in some cases, members might have special characters or spaces, say for example like the global rate table. In that case, we have to enclose the member in quotes. In S-base, a block is analogous to a tab or a worksheet in Microsoft Excel. In some cases, you want to pull data in a formula that's all from the same tab. In some cases, for example, here global rates might be stored in a separate tab from the volume and the calculated amount. In S-base, in business rules, we deal with this through a cross-dimensional reference. The cross-dimensional reference, highlighted in yellow, is a dash and a greater than sign. And what it's saying is it's saying I want to multiply volume times rate, but I want to take the rate from another block, or in the terms of Excel, I want to take the rates from another tab. Assignment statements can use functions. Functions are preceded with the @ sign, and they're followed by enclosed parentheses containing the required arguments separated by commas. Within some business rules, within some calculation, it's necessary to use if, then, else logic. In business rules, that logic, if statements, must be done inside of a calculation block. Now, there are other reasons that a calculation block may be needed. However, if a calculation block is not required, it's generally best not to use one. But for the purposes of this session, we're going to talk about calculation blocks as something that's necessary when we want to apply if-then-else logic. To create a calc block, we reference a member that will be implicitly a part of the left-hand side of all the assignment statements within that calc block. After referencing that member, we start with an open parentheses, then we put our logic inside of the calc block, and we end the calc block with a closed parentheses. You can see that in this case, we're testing to see if the hours in our calculation is greater than 0. For example, if we are calculating the cost of labor, we may want to make sure that we don't have a negative value coming in to the labor account. As you begin working with business rules, the S-based technical reference, or TechRef, will be a very valuable resource. It will help you with things like syntax, understanding what the commands are, and understanding what the functions are and what they do. In most business rules, functions are at the heart of the calculation, and they can be categorized into some general groups. There are Boolean functions. Boolean functions are functions that return a true or a false. and they're often used in the control flow commands such as if then else. There are relationship functions and member set functions that will return members as their result, and they're used in fixed statements. Finally, there are mathematical functions and date and time functions which return numbers and dates, and they're used on the right-hand side of assignment statements. There's an interesting quirk in business rules. In most programming languages, dividing by 0 returns an error. For example, in Visual Basic or Java, if I divide the number 150 by 0, I will get an error. In business rules, dividing by 0 or pound missing returns 0. Pound missing just means that the cell is blank. It doesn't even have a number. But mathematically, pound missing works just like 0. Whether in a programming language or in math, dividing any non-zero, non-missing number by itself returns 1. So if I divide 10 by 10, I get 1. If I divide 123 by 123, I get 1. If I divide x by x, I get 1. And therefore, in business rules, anything divided by itself returns either 1 or 0. No other value is possible. And ones and zeros can be used in place of if statements to control the flow of a business rule. When doing calculations for a forecast, we have to separate months that contain actual data from those months that we have to forecast using a formula. We might use a flag to do that. So we could establish an account called flag, and in that flag, actual periods are represented by 1s, and forecast periods are represented by 0s. And we could code a calculation that said, if the flag equals to 1, then return the value from the actual scenario. Otherwise, give us our forecast formula, which would be volume times rate. One of the things that you'll notice is that there's a double equal sign between flags and 1. We use a single equal sign to do an assignment, but we use a double equal sign to do a comparison. So we have one way of representing it with an if-then-else construct, but we can use the 1s and the 0s that we talked about to manage the calculation without having to use ifs. So I can simply say that my amount equals to my flag times actual. So when the flag equals 1, it will return actual. The bottom term, 1 minus flag, 1 minus 1 is 0, so that when the flag is 1, I'll get the top term. It'll return actual and not do the forecast calculation. In months where the flag is 0, I'll have flag times actual, 0 times actual, and the top term will go away. 1 minus flag is 1, so I'll be multiplying my forecast equation times 1, and I'll get my forecast equation. And so I can do a control flow in this case using 1s and 0s instead of having to use if-else.